Hello, this is Dr. Mears, and today we are going to be learning about the sine rule. The sine rule helps us to find the side lengths and angles of non-right triangles. Yay! The sine rule is A divided by sine of A equals B divided by sine of B equals C divided by sine of C. Here's the thing. We only use two at a time, so we can use those two. Here's our examples. Number one, find side BC. So what they want us to find is BC right here, this side. So let's look. This side is across from angle A. So this is little a. The capital letters represents angles. Please remember that. The capital letters represents angles. The lowercase letters are sides. So keep your angles and sides straight, please. Well, straight angles are 180, but that's another lesson for another day. Okay, let's see what other information we have in this triangle. We also have angle B and we have side B. Now, you don't really have to worry about the letters as much as you make sure you have an angle and a side, or an angle and a side. And know that you're just going to put the side lengths in the numerator and the angle lengths and the angle degrees in the denominator. What do I mean by that? Well, let's take the 38 degrees and side A. So we are looking for side A. So that goes in the numerator because that's a side. We don't know what it is, which is fine. Then we're going to write sine of sides A opposite angle 38 equals. All right, who else do we have? We have the 12, this 12 centimeters. That's a side length, so 12. Its opposite angle measurement, sine of 44. So even if I didn't have these letters in, it's okay because you just have to match up the angle with its opposite side. Please remember that. You're matching up the angle and its opposite side, or the opposite side and its angle. We use two of them, we're ready to go. Now there's a couple different ways to solve this, and I would like you to pick, I'm going to do both, and I would like you to pick your way that you like, that's the easiest for you. Okay, so here's the first way. I'm going to write this over. Okay, so the first way, you don't have to erase that number one, I'm just moving it up, is because we need to solve for A and it's linked by division with sine of 38, we can simply multiply both sides by sine of 38. A equals. Then we take out our calculator. Now here's the important part with our calculator. Clear all that out. We're going to put in 12. Then we're going to push the division symbol. Then we're going to put sine, and notice how my parentheses open up. 44. You have got to, I repeat, you have got to close those parentheses. Then we can do multiplication times sine of 38. Again, close your parentheses. This will do it all for you. You don't need any other parentheses. I'm not going to confuse you. You can do it all in one step, and we get 10.635. I'm going to go three significant figures, so I'm going to do 10.6. So A equals 10.6 centimeters. So that's this side. Okay, so that's the first way to do it. The second way to do it, which you might see me do in other, for another example, is cross multiplication. So we could use cross multiplication where we're multiplying across. So denominator with numerator, denominator with numerator. So we're going to come out with sine of 38 times 12 equals A times sine of 44. Okay, and I'm actually, oh no, I can leave that there. And then I can divide both sides by sine of 44. So A equals, now in the calculator, here's the thing. We're going to do sine of 38. You have got to close those parentheses around the 38. Close them. Times 12 divided by sine of 44. And we get 10.6. Again, remembering to close all of those parentheses. A equals 10.6 centimeters. The same exact answer. that I got over here, but just two different ways. This is, I feel, the easiest, but whatever you want. You are going to see me use this way a couple times, so now you have both. Okay, so that was solving for a side. Let's now solve for an angle. For this one, we're looking for angle C. So again, find your sides and their opposite angles. So here's 20, we have opposite angle, and we have 12, and we're looking for this angle measurement. We're looking for theta right there. All right, so let's set it up. I'm going to work with this side first. So we have 20 divided by its opposite sine of its opposite angle, 88. Okay, match up, equals. I'm looking for, I have side 12. And I'm looking for sine. And you can write, we could write C here. Or you could write theta, at either one you want. This is small c, and this is small a. And if you want to match the letters up, that's fine. But again, I like just picking out the side goes in the numerator, the sine of the opposite angle goes in the denominator. Okay, the side goes in the numerator, the sine of the opposite angle goes in the denominator. That's how I like to remember the sine formula. All right, now we have to solve. So again, we could do it a couple different ways. We could multiply by sine C. I'm going to use this. I'm just jumping there, everybody. So I'm just going to do cross multiplication. So right now I'm at 20 times sine C equals 12 times sine of 88. Okay, this is linked by multiplication. So what are we going to do? Right, we're going to divide. Divided by 20, divided by 20. Sine C equals 12 times sine of 88 divided by 20. Notice that I ran out of paper. Okay. Notice I'm not doing anything in the calculator yet because I'm going to do it all in one step. It's really nice. But I haven't solved for an angle. Remember, when we solve for an angle, we have to take the inverse of sine. Inverse gets you inside the triangle where the angles are. Let me say that again. Inverse gets you inside the triangle where the angles are. So I'm going to rewrite everything. Sine of 88 all over 20. Okay, let's put this in the calculator. I'm ready to go now. So take the calculator out. So I need inverse. So we're going to do second sine. Remember, that's inverse sine. 12 times sine of 88. Close those parentheses, everybody. Divided by 20. And then I'm going to close these. So these two parentheses right here match up, and I'm making sure that those two are closed as well. Enter, and we get 36.84. Whoops. So I did like that. So C equals 36.84. So 36.8 degrees. So that's this angle right here is 36.8 degrees. Yay. And just to point something out because you might need it, if we needed to solve for the angle B here, I just want you to remember that adding up all of the angles in a triangle, angle A plus, angle B plus angle C equals 180 degrees. Just a little review for you. So, you could add these two up and then subtract from 180, and that would get you B. I'm not going to do it. I just wanted to remind you of that little tiny fact. Okay, let's go to our last example, and that is called the ambiguous case, dun, 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 where there could be two possible triangles with different angle measurements. What do I mean by that? All right, so let's look. I'm going to have to divide my paper out because there's going to be two. So we have a triangle ABC. Angle B, 34 degrees. The measurement of B, side B, is 15 centimeters. The measurement of side C is 20. Find two possible values for angle C. I am going to ask you to find two. That's how you know you're going to have to find two. I will make sure I specify in the problem. Okay, so our first triangle here. First possibility. And that's where we could have an acute triangle. Here's angle C. Let's see, let's go A and B. I like writing my numbers clockwise, so A, B, C. Now you get it. Okay, so angle B is 34 degrees, so that's that angle. Let's put, so the opposite, so this is little b, that's 15 centimeters. Side C, here's C, that's 20 centimeters. Okay, that's the first possibility. The second possibility is where angle C can be obtuse. See what I'm throwing down here? That's 34 degrees, B is 15 centimeters, C is 20 centimeters. Okay, and we're going to have to find angle C. Find angle C. So one could be acute, oh, little cute, which means it's less than 90 degrees, or one could be obtuse, which is greater than, obtuse, greater than 90 degrees. All right, so let's do both. First, let's find the first possibility. It doesn't matter which one you do. It's going to work out, so I'm going to show you how to find both. But let's use our sine. So let's see what we have. So first, we have a side measurement, and we have its opposite angle. We need these two. So side in the numerator, sine of the opposite angle in the denominator, equals, okay. We need angle C. We have its side. So side 20, sine of C. Okay, I'm going to cross 20 times sine of 34. Cross equals 15 times sine C. Divide because it's linked by multiplication. So hopefully you see what the same type of steps that are happening here. We're not done yet. Oops, sorry, ran out of paper again. So the same type of steps. I have to divide, so I'm dividing. I'm not doing any work yet. Why? Because I have to find the angle measurement. Angle means I need to do the inverse to get inside the triangle. And now I can do it all in one step. Bring my calculator over here. Let's clear that. Inverse sine, 20 times sine of 34, closing those parentheses, divided by 15, closing the first set, enter, 48.2. So C equals 48.2, little tiny 0.2, 48.2 degrees. So that is my first angle measurement. That is my acute angle measurement, because remember, acute is smaller than 90. Right there, acute. So that's my first possibility. Boom. All right, how about my second? Well, here's the beauty of this. What we could do, all we need to do is we can just take 180 and we can subtract that acute angle C, 48.2 degrees. And we're going to get the other angle, everybody. Honestly, that's all you do. So we're just going to do 180 minus 48.2, and I get 131.8. That is my acute angle. So all you need to do is 180 minus your angle measurement, whatever you get, and you get the other angle. Yay! So that's the ambiguous case, where it could be 48.2 are acute or 138.1 are obtuse. And we just found this by simply doing 180 minus that angle that we found. First angle. First one found. Gives you that other angle. Okay. This has been Dr. Mears with the sine rule and the ambiguous case. Hope it helped.